Sam, did you write out part A? Do you kind of want to take us through your answers here?
Yeah, so you start by plugging x into g, and then you plug the g of x into the equation, and then you have to simplify by FOILing, because it's the 3x plus 5 squared. So you
Yes.
FOIL that, and then you can combine like terms, and then get your answer.
Awesome, awesome job there. Yeah, so I like how you went through this step by step. You showed your foiling steps and it simplified very nicely when you did the step by step. Any questions on part A? Right. Part B, was that Amelia?
Yeah.
Amelia, do you kind of want to take us through your steps?
Yeah, so I did G of P of 2, and then I plugged in plugged in -2 for the P of x equation for x. And then I got G of 2, and then I plugged in 2 for the G of x equation for x and got 11.
Awesome, good. I like how you kind of did each step separate, right? You put parentheses around the -2, so when you squared it, it turned into a positive number, and we got 11 as our final answer. Nice job on that one. Any questions on A or B? Okay. Number 5, Lila, right? You want to take us through your steps?
So I rewrote the equation, and then I just have it put the g of x to y equals. And then I put the inverse translation after the y. And basically I just solve for y after that.
Awesome. Good job on that one. Any questions on inverse functions? All right. And the last one, I didn't ask anyone to write it up because I think most of you guys got this one right. I just kind of sketched the graph here. It's an exponential graph. Remember, the asymptote is the x-axis, and it kind of increases as you go up, and it gets closer to the x-axis as you go down. Any questions on the last two? All right. So I think there's some traffic going on Camden. So I think we're going to have some stragglers coming in. So what we're going to do is we're going to do a little warm up. And I have to figure out where I put my warm up. I think it's here. Here we go. Okay. Does anyone need the board? Okay. I'm going to put 3 little warm up questions. They're not written on your guided notes, okay, but I do want to go over them really quickly. Okay.
Warm up time, open up your books and start writing stuff in them. Warm up time, uncap your pen and please solve the equation.
All right, let's come back together. I know if you're still working on it, don't worry. This is kind of just to jog our memories and get ourselves back on track, okay? The first one. Okay, so we have a combination of like equations and then things that are expressions, things that don't have an equal sign, okay? First one is an example of an expression because there's no equal sign. We're not solving for x, we're just figuring out what this number is, right? Okay, so what I like to do here is the big question is, what is that equal to, right? So log base 5 of 25 equals something, right? We want to know what that something is. Now, there's 2 methods to kind of think about this. You can think about it in words, or you can visualize it using exponentials. Does anyone kind of want to take me through what their thought process was? I saw some good answers, so don't be scared. Stephen?
Just take 5 and multiply by 5. And actually just get to the big number.
Yeah, so 5 times 5 times 5 times 5, or like an exponent, right? 5 to the what power equals 25, right? That's basically what the question is asking. Okay? So 5 to the what power equals 25? What is the power? 2, good, right? 5 squared equals 25. So the answer is very simple. It's just 2. Okay. Any questions on this example here? Good. Okay. Let's take a look at this one. Log base 2 of x equals 20. Okay, this one is an example of an equation. We have to solve for x, and there's logarithms mixed in there. So now we have to work with inverse functions, just like addition and subtraction, multiplication and division, the cube and the cube root. Those are things that cancel each other out. Logarithms and exponentials cancel each other out. Okay, so we have a logarithm. It's by itself on the left-hand side, so we don't have to like isolate the logarithm. You don't have to get the log by itself. It already is. Okay. What did you guys do to get x by itself?
You would like multiply the log 2 on both sides.
Oh, okay. So I think I see what you did. I'm gonna write this down. Now, making mistakes is totally fine. So I think this is it's always good to do something wrong and see what happens. Okay, so if I took log base 2 of both sides, well, a log doesn't cancel out a log, exponents do, right? So doing this wouldn't actually cancel out the log base 2. Okay, any other ideas on what we could do? Not square it, but take it to the power of 2, or I don't even know how to say it, but 2 to the power. Do you see the difference between these two ways? Good. So it's always good to just write down what it looks like when you see it. I think if you write it down, you'll kind of be like, oh, well, now there's 2 logarithms. That doesn't look quite right? But this looks a little bit better. Okay, so to undo a log, we do 2 to the power of each side. Okay, now on the left-hand side, the 2 and the log base 2 can cancel each other out, but the x doesn't get canceled out. Okay, so the only thing that gets canceled out is the words log base 2. The x stays the same. So on the left-hand side, what are we left with? X, good. And on the right-hand side, we're left with 2 to the 20th power. Okay, now you can go in your calculator and figure out what 2 to the 20th power is, but if you want to, you can just leave it as it is. Any questions on this example? So very simple. When you have logarithms, all you have to do is take 2 to the power of the log and you're good. Okay, let's go to the last one. This one says 3a to the 2x equals 15. We want to solve not for a, but for x, right? A is just the base of our exponent here. Okay. What did you guys do first here? Yeah, divide by 3, right? The a to the 2x here is messing things up. And to undo the a, we want to get the a to the x by itself, okay? So dividing by 3 should be the way to go here. Okay. On the left-hand side, we're left with a to the 2x. And on the right-hand side, 15 divided by 3 is, oh my gosh, I was about to say 2, 5. Good, 5. Nice job, okay. Okay, so we have an exponential. We have x in the exponent and we have a on the bottom. What did you guys do to isolate the 2x? Yeah, do log base a, good, on both sides. Okay, so we're just taking the log of both sides. I chose log base a because a was the base of the exponent, okay? So the left-hand side, we cancel out the log base a and the a, and I guess we're left with 2x, right? On the right-hand side, log base a of 5. Okay. Now we want to get x by itself, so what's the last thing we should do? Divide by 2. So x is equal to log base a of 5 over 2, okay? You can leave it like this. I don't mind writing it like this. Sometimes I like to take the 2 out and make this 1/2 times log base a of 5. So either way is fine to me. Any questions on any of these 3 questions? All right. I think we're on the right mindset here. So what we're going to do is go to our guided notes. No one needs the guided notes. Okay. I'm going to unmute myself. 5.2 through 5.4. We've dealt with exponents. We learned how to draw the exponential functions. We talked about that natural exponential function e to the x, right? E is just a number, kind of like pi. And then we started talking about logarithms, and we were able to answer questions that looked like the ones on the board, right? Okay. So we got through solving equations with logs and simplifying these guys here. Okay. Now, I think things are going to get a little bit easier from now on with this section, okay? We're going to talk about two shorthands for logarithms, okay? So let's take a look at this box, okay? Now, if you go into higher levels of math or physics or something like that, you might see logarithms, but they're not going to be written the way that we wrote them before, okay? Sometimes you're going to be going through a test or going through calculus or something, and you're going to see just log x, okay? If you see this, the only thing this means is log base 10, okay? The reason we do this is because log base 10 is used a lot in real life, okay? We have what's called a base 10 number system that's commonly used. We have 10 fingers to count things, 10 toes, right? So whenever we normally count things, we usually count to 10, right? So that's why log base 10 gets simplified to log base x, or log of x. We also have ln of x. Okay, I know people kind of get scared when they see this number being thrown around all the time. Ln of x is literally log base e of x, okay? We call this the natural logarithm because, well, e is natural, right? It comes, oh my gosh, I get so like nervous when I see the people walking up. Anyway, that got me scared. Okay, okay. The tourists come over and I feel like they're judging me. They're like, oh, what you talking about? Okay, so
They probably think you're done.
yeah, they're like, oh, she don't know what she's talking about. Okay. What type of pearl is that? I'm not going here.
And you're wearing a different top.
I know, they're like, oh, she doesn't even like the school. She likes the other school. I'm gonna go there. All right, so I don't even know what today is. Okay, so ln of x is literally just a log of e. The reason we have a simplification for this is because, well, e shows up in a lot of different scenarios, right? Temperature, half-lives, anything involving chemistry, things that happen naturally in real life uses that number e. So we have a little shorthand for it. Okay. All right, example number 11, okay? Now I'm gonna do example 11, I'll let you do example 12 on your own, okay? Whenever you see an equation, just like these two examples up on the board, and it involves log or ln, it's literally the same thing as what we've been doing before, okay? But what I like to do is log x is log base 10 of x, right? So instead of writing log x, we can literally just put the base in and everything would be fine, okay? So very, very similar to this middle question with the log base 2 of x. What should we do on both sides of the equation? Yeah. Yeah, it's a kind of tricky to say it, right? Oh, Steve.
There can just.
Oh, that's actually a really smart way of thinking of it. Yeah, you know what? Okay, if you think of it that way, totally good. We'll talk about like logarithm laws really soon, and you'll actually kind of see how that comes about. But yeah, if you want to plug in numbers and see what happens, totally fine with me. But nice, that's a nice way of thinking about it. I didn't actually think about that before, but good job on that.
I just flip it, like, you know how you said like it's
Mhm.
a base and then it equals, so I just flip it and I do the 10 to the third equals x.
That's a smart way of looking at it too. Huh. Okay, I'll show you my way of doing it. If you have a different way of doing it, props to you. I respect any other way of doing the question as long as it's not wrong. Okay. So the way I see it is like canceling out. Of course, plugging in numbers or flipping the form would do that. So anyway, however you get it, x equals 10 to the third power is the answer. Okay. Any questions on example 11?
So that would work.
Yeah, plugging in 10 cubed, if you see it that way, that's pretty good. Yeah. Yeah, just the way that it's set up. I mean, that works for me. Yeah. Yeah, actually, I think that's like a smarter way of looking at it, more intuitive than the way I do it, but yeah. All right, try example 12. It seems like most of the class is done. I know I didn't give much time for this one, but let's just go over this one, okay? ln of x, that's the same thing as saying log base e, right? So I can rewrite this question as log base e of x equals 4.7. And what did you do to each side of the equation? Yeah, e to the power, right? So you did e to the log ex power, and then you did e to the 4.7 power, okay? Or you could have thought about it in your head, right? The e's cancel each other out, and the log base e. Okay, so on the left-hand side, we're left with x. On the right-hand side, we're left with 4.7. Any other method you find easier doing that, totally fine with me. But this is what I got. Any questions on example 12? Do we feel comfortable with solving logarithmic equations? Nice. All right. So one last topic of this section. Okay, we're going to talk about how to graph logarithmic questions. We've done graphs of exponential functions, right? Just like in our quiz. And the logarithmic functions are the inverse of exponential functions. So our graph is probably going to look very similar to this, but it's going to be some sort of reflection, right? Okay. So here, we're going to make an X and Y chart. Oop, that's really bad. Oh my goodness. Oh my gosh. There we go. Okay. And we're going to plug in some values of X, and we're going to try to figure out what the Y values are. Okay. Let's plug in X equals 0 first. Let's see what happens when we do that. Okay. If we plug in X equals 0 into the equation, the Y value is going to be ln of 0, right? Okay, which is log base e of 0. Okay, so two ways you can do this. I really don't mind if you go in your calculator and type in ln of 0 or log base e of 0, okay? Another way we can think of this is, well, e to the what power equals 0, right? What power can we raise e to get 0? It's a trick question, isn't it, right? Yeah. You can't raise a number to a power and get 0. We can raise a number to a power and get 1. We can get fractions, but there's nothing that we can do to raise a number to a power and get 0. Okay, so this answer does not exist. Ooh, does not exist. There is no y value such that x equals 0, such that ln of 0 equals something. Okay, so let's take a look. On the graph, when something doesn't exist, what does that turn into? Ooh, I heard it, an asymptote, right? Something that the graph gets really close to but doesn't touch, right? And is it going to be a vertical asymptote or a horizontal asymptote? It's actually going to be a vertical asymptote because, well, when x is 0, there is no y value, right? So there's nothing that can be on that vertical dotted line. Okay, so just like how the exponential function has a horizontal asymptote at y equals x, the logarithmic function has a horizontal asymptote at the y-axis. Oh, sorry, I said y equals x, I meant the x-axis. Logarithmic functions have an asymptote at the y-axis. Okay. Any questions so far? Okay, did it matter that it was log base e here? Could have been log base 5. Okay. If this was log base 5 or log base 7, there would still be a vertical asymptote at the y-axis, right? It didn't matter that it was log base e here. There's nothing you can raise any number to a power to get 0. Okay, so this is common for all logarithm functions. Let's plug in x equals 1. Okay. Natural log of 1. Okay. You can either type this in your calculator, or you can think of this as e to the what power equals 1. What power can I raise something here to get 1? 0, right? And that works with any number. Log base 5, log base 7, anything to the 0 power equals 1, right? So this equals 1. Oh, sorry, this equals 0, right? So we have a 0.1, 0 on our graph. This point, oh, yeah. Oh, so this is the same. So I got 0 because e to the 0 equals 1. We plugged in 1 into the log function, right? Okay, here. Oh, okay. Yeah, I feel like I threw in a bunch of numbers at you guys just at once. Okay, so 1, 0 is the point on our graph. It doesn't really matter that it was ln this time, okay? So this point and the asymptote is pretty much common for every single logarithmic function, right? It doesn't really matter that we dealt with this specific one. Okay. Now, to get the second point that I'm going to draw, it kind of depends on the function, okay? If you plug in like 2, you're probably not going to get something nice. If you plugged in 3, probably wouldn't give you something nice. Does anyone want to give me a hint on what I should plug in? Maybe something based on the function I can plug in? What about e, right? If I plugged in 2 or 3 or 4 in for x, I'm going to get a weird decimal. So maybe a smart move would be to plug in the base of our logarithm, okay? So ln of e. Okay, remember, type in your calculator, or you can ask e to the what power equals e, right? What power of e gets itself back? E to the first, right? E to the first power is itself, right? Anything to the first power is itself. So this y value would be 1. Okay, so e is about what, 2.718. So around x equals 2.718, y is equal to 1. Okay, now this point does depend on what function I gave you. If it was log base 5 of x, well, it'd be 5, 1, right? If it was log base 4 of x, it would be 4, 1. But since it's log base e of x, the point is e 1. Okay. Now, at this point, I think we have enough information to create our graph. We know that we're going to be increasing as we go to the right because the graph looks like it's increasing. And we have that asymptote at the y-axis. So we know that the function is probably going to decrease toward the x-axis. It's going to look very similar to the e function here. So if we connect these dots here, our function is going to look just like that. All logarithm functions have this shape. Okay, it's going to look like this. And if you have 2 points and the asymptote, you're good to go. Okay. Any questions on graphing logarithmic functions? Okay, I don't have more practice for you guys. I'll put up a practice worksheet if you want to work on finding these guys, but I think it's pretty easy once you know how to do the exponential ones. But if we don't have any more questions on this, we can work on our next section. All right. So the new section. So, yeah, sorry, I didn't really cover that today, didn't I? E is a number, it's just 2.718. It's just a number, just like pi. questions? All right. So new section here, we're doing section 5.5, properties of logarithms, okay? I feel like this section is something that's very important once you get into higher level math classes, if you plan on doing that. If you plan on taking calculus, you're probably gonna see this a lot. Okay, what was I gonna say about this? I would say I work a lot with the tutoring center on this thing called the calculus gateway assessment, where you kind of test calculus students on the stuff they learned in high school and in Math 140. And I feel like this is the thing that a lot of people forget, okay? And it frustrates a lot of calculus professors that they're like, oh my gosh, they don't know how to do this. And I'm like, they took it in high school, so can't blame them. But I'm going to drill this in your head so we are very good at doing properties of logarithms so my colleagues don't yell at me next semester. And let's go through some of these guys here. So we've dealt with logarithms. We know how to solve them. We know how to solve equations that involve logarithms. Now what we're going to do is try to look at how we simplify logarithms. Okay, we haven't dealt with any simplification steps except for solving like logarithms involving numbers. Okay, so let's take a look at these three rules. If they look a little confusing right now, don't freak out. We'll go through what they mean. Okay, so when we deal with logarithms, we always have the base a, right? So this a here is just whatever the base is. Okay, and this first rule is telling us when there's multiplication involved in the inside of the logarithm. So two numbers or variables or a mix of the two being multiplied inside the logarithm, we can turn this into addition of two different logarithms, okay? The base will stay the same as we do this, but we can break apart multiplication on the inside into addition on the outside, okay? Now, if you don't like looking at letters, I'll give a little example here. Log base 2 of 3x. Okay, so there's multiplication going on inside the logarithm. There's a 3 times an x. How would I expand this into two different logarithms?
Would it be log base 2 of 3?
Mhm.
Log base 2 of x.
Awesome, I wrote that down completely wrong. Log base 2 of 3 plus log base 2 of x. Okay, so whenever there's multiplication involved in the inside, we can expand it out to the addition of two different logarithms, okay? And it doesn't just go the forward direction. If you were given this addition and you didn't know what the left-hand side said, you could combine those two logarithms being added into one big logarithm, right? Log base 2 of 3 plus log base 2 of x is just log base 2 of 3x. So this rule goes both ways. You can condense a logarithm or group of logarithms into one, and you can expand one logarithm into a bunch of them. Okay. Now, we've done multiplication, so of course we have to talk about division. Whenever we divide two numbers inside a logarithm, we can expand that out into subtraction of two logarithms, okay? So log base a of u minus log base a of w. Okay. Finally, we have to talk about exponents. Okay. Whenever we see an exponent inside a logarithm, we can just move that exponent to the front. Okay. So for example, log base e of 2 cubed, what would that become? Awesome, right? So we can just move the exponent to the front. Now, on the other hand, if we were given the 3 log base e of 2, we could move the 3 to the top and get the left-hand side, right? So this goes both ways. We can kind of translate between each of these ways of writing a logarithm. Now, there is a warning, okay? This works for multiplication inside the logarithm, division inside the logarithm, addition outside the logarithm, right? So if we have addition on the inside of the logarithm, like log base A of u plus w, or log base A of u minus w. You cannot split up the addition into two different logarithms, okay? You can't modify this rule to include addition on the inside, okay? On the other hand, you can't multiply two logarithms and combine them into one, okay? You can't modify the rules to include multiplication on the outside, okay? So this only works multiplication division on the inside, addition subtraction on the outside. Okay, let's do an example. If that's a little confusing, I think these examples will kind of lead you through how we do these, okay? This is asking us to express log base 5 of 3x squared square root of y in terms of logarithms that include x, y, and z, okay? Now, in this question, there's no z, so z doesn't really make sense here, but I think your homework expresses questions just like this. Okay. Let me just explain what this question is telling us first, okay? We want to express things in terms of logarithms of x and y. What this means is our final answer will only have log base 5 in this case of x, log base 5 of y, or log base 5 of a number, okay? There's not going to be any log base 5 of 3x or log base 5 of y squared, okay? We're only going to have these specific phrases in our answer, and if there's something else, then it's not part of the log. Okay. Any questions so far? Okay. Let's try this one. So I'm going to just rewrite the question here. Okay, now I'm scared that I didn't. So I think I'm good. Okay. Okay. Oh, thank you. I totally forgot that. Square root of y. Thank you for that. Okay. Now let's take a look at this. We have multiplication going on. We also have exponents going on, right? And don't worry about the square root yet. Okay. We can't apply rule 3 yet because the square and the square roots are attached to the x's and the y's, but we haven't like isolated the x and the y by itself yet, okay? So let's work on the multiplication first, and then we can do the exponents later, okay? So any ideas on how to expand this a little bit? Mm-hmm. Mm-hmm. Yep. Awesome, awesome. So basically what you saw is there's multiplication going on inside the logarithm. So we can take that multiplication and turn it into addition on the outside. Does everyone see how we got this answer? Okay. Nice. So log base 5 of 3, can't really do anything with that yet. There are exponents going around. Any ideas on what we can do with the exponents? Good, we can bring that 2 up front. Okay, let's do that, and then we'll deal with the square root in the next step. Log base 5 of 3 plus 2 log base 5 of x plus log base 5 of the square root of y. Now we haven't talked about square roots, cube roots, fourth roots in these rules. Does anyone remember how we can rewrite the square root of y? I think I heard something. It's y to a power, but it's not y squared. It's y to the 1/2. Good. Remember, square roots is the same as the 1/2 power. Cube roots are the same as the 1/3 power. Fourth roots, 1/4 power. So we can rewrite this as y to the 1/2. Any ideas on what to do next? Awesome, move the 1/2 out. So this turns into log base 5 of 3 plus 2 log base 5 of x plus 1/2 log base 5 of y. Okay. Now, I know it kind of looks like it's done. We've represented everything in terms of X, Y, and a number, okay? But there is one thing I want you to check in case you do WebAssign, okay? So in case you see this on WebAssign, you might get to this step and be like, okay, I'm done. But let's just check this one, okay? Now, log base 5 of 3. That kind of looks like this question, log base 5 of 25. And we were able to simplify that down to like a whole number. Mhm.
That doesn't work.
Yeah, and why doesn't it work?
Because 5 can't be square root anything.
Yeah, right. There's no like whole number that makes 5 some to the something power equal 3, right? So because this turns into like a weird funky fraction or decimal or whatever, I'm just gonna leave it just like this, okay? But if you're doing your homework and you see log base 5 of 25 instead of log base 5 of 3, that might be a good idea that you have to simplify it to like a whole number, okay? So if it works out nice, go ahead and do that, but I'm totally fine with you leaving it just like that. Okay. Any questions on example 1? Okay. Let's quickly do example 2. It's very fast, okay? Example 2 is asking us to write log base 2 of x squared plus y in terms of x, y, and z. Okay. What do you think we can do here? Can't do anything, right? Yeah, right. I like how you say that. Okay, the logarithm rules only work if we have multiplication on the inside, right? Is there anything being multiplied on the inside? No, right? So there's no multiplication on the inside, so we can't do anything here. Okay, am I going to try to trick you on the quiz or test using stuff like this? Probably not. But just make sure if you see this, know that you can't do anything unless we have multiplication on the inside. Okay. Any questions on example 2? All right. I don't think there's anything like this on WebAssign, but if there is, I'm very sorry. Talk to me about it. Okay, but I don't think something like example 2 is on there. All right, next class, we'll start with example 3. We will be meeting in Devilbus Hall, and I will see you then.